Hello, welcome to Chapter 8, homework questions 58 to 63. Question 58, graph y equals x squared minus 8x plus 7 and label its vertex, x-intercepts, and y-intercepts. So let's go ahead and create a table. Let's see what we get here. If we plug in 0, we're going to get 7. Plug in 1, we'll get 0. 2 will be negative 5. 3 is negative 8. 4 is negative 9. And remember, it is a quadratic. We know it's a parabola or U-shaped graph, so we are looking for some repeating values. So I'm going to go a little farther. 5, I'm going to get negative 8. There's that repeat that I was looking for. 6, I'm going to be negative 5. And we can see the symmetry the rest of the way. 7 will be at 0. And then 8 will be at 7. So just plugging these numbers into the calculator. For example, on 1, you have y equals 1 squared minus 8 times 1 plus 7. And then when you plug in all those values, you can just keep doing the same thing. So that's the t-chart I have. I'm going to go ahead and plot those points. When x is 0, y is 7. So that would represent the y-intercept. X is 1, y is 0. That's an x-intercept. 2, negative 5. 3, negative 8. 4, negative 9. And then we have the symmetry. So our graph, missing some points, but general idea there. And it also wants us to label its vertex and x-intercepts and y-intercepts. So the y-intercept, we have at 0, 7. The x-intercepts, and there will be 2 of them, is at 1, 0 and 7, 0. And then the vertex is the minimum point, and that's at 4, negative 9. And we've graphed the equation and labeled vertex, x-intercepts, and y-intercepts. Question 59. What is special about the number 0? Think about this as you answer the questions below. Find each sum. 0 plus 3 is 3. Negative 7 plus 0 is negative 7. 0 plus 6 is 6. And 0 plus negative 2 is negative 2. What is special about adding 0? Write a sentence that begins with, when you add 0 to a number, it does not change the value of the number. Okay, C says Julia is thinking of 2 numbers, A and B. When she adds them together, she gets a sum of B. Does that tell you anything about either of Julia's numbers? If the sum is B, then we know A is equal to 0. Find each product. 3 times 0. 0, negative 7 times 0 is 0, 0 times 6 is 0, and 0 times negative 2 is 0. So what is special about multiplying by 0? Write a sentence that begins, when you multiply a number by 0, the result is always 0. So what do we find out here? When you add a number to 0, you get that value back, but if you multiply a number by 0, you will always get 0. Question 60. Based on the tables below, say as much as you can about the x and y intercepts of the corresponding graphs. So with the x-intercept, we're looking for x values when y is 0. And we have it 2, 0, and 3, 0. And the y-intercept is when x is 0, and that will be at 18. And I just realized I missed a x-intercept at negative 4, 0 also. So put that one in there. Table 2, the x-intercept, 3, 0. And we have another one at 8, 0. And then the y-intercept is 0, negative 3. And for the last table, x-intercept, I see one at 1, 0. I don't see any more. And then the y-intercept is at 0, negative 4. So just remember, when you're trying to find the x-intercepts, you're looking at where the graph crosses the x-axis. So that is when y is 0. And when you're looking for the y-intercept, you're looking at where the graph touches the y-axis, and that is when x is equal to 0. Question 61. In speed golfing, an athlete's score is determined by adding the number of strokes to complete a course to the minutes required to finish. For example, 90 strokes in 51 minutes would be a score of 141. The lower the score, the better. Diego wants to see if there is a relationship between the time it takes for him to complete a speed golfing match and the number of strokes S he takes in the same match. If so, perhaps focusing on running faster will also reduce the number of strokes. So you can see that you have a table, time and strokes. Time is your independent, strokes is your dependent. We want to create a scatter plot, determine Diego's best score, and circle the point representing Diego's best score. So I went ahead and included the scatter plot on here, which is down here. So you can see the scatter plot there, and it does want to know which score is his best score. So we'd have to add all these numbers up and see which one is the lowest. And so I went ahead and added them all up, and it appears that the 122 is the lowest. So we want to circle that on the graph, and that would be that point down there. 45 is the time in minutes, and then 77 will be the score. So a total of 122, or 77 is the strokes, 122 would be the score. So I went ahead and answered part A. B, discuss what you can about the association from the observation of the scatter plot. And so you can see that answer right down here. There is a weak to moderate positive linear association. So you can see we got a nice set of points up here. It looks like it's positive. It is increasing between Diego's run time and the strokes taken for each match. There looks to be an outlier at 92 minutes. So right over here, this point is really pushing the data, farther that way. So it seems to be an outlier. All right, on part C, Diego recalls that he was suffering from seasonal allergies that slowed his running on a particular course. Cross out that point, then use your intuition and draw a line of best fit from the remaining points. So it does appear there's an outlier at this one right here, so we're going to cross this one out, which is right here. And then we're going to draw in a new line of best fit for the remaining points. And so I drew one in, try to balance those points a little bit better without that outlier in there. D says estimate the slope of your trend line and interpret in the context of the problem. So everyone's going to have a different line and a different slope. So no matter what your slope is, here's the answer to part D. Your number might change, but it's going to be the same idea. For every minute of improvement in time, reduces the number of strokes by 0.7 on average. Now, like I said, yours might be a little different than that, but the statement will still be the same. For every minute of improvement in time, reduces the number of strokes by whatever you have in terms of your average. And then part E, should Diego train to reduce his time so that he sees a decrease in his golf scores? So on this one, I once again provided the answer key from the book on this one. There's a lot of different things that you could say in terms of, should Diego train to reduce his time so that his golf score goes down? The book says the variables are moderately associated, but that does not mean that one variable causes the other. So that's that causability that we talked about. It does seem reasonable that training for conditioning could improve Diego's aim and confidence in his golf swing. However, the potential exists that a better, more accurate swing could also reduce the amount of running required on the course. So therefore, it's not clear what causes what, or if there is a third lurking variable in there. So once again, on that one, a couple different things that you could say, but it definitely doesn't necessarily seem that it is clear that, what causes it. And there could be another variable out there as well. 62. Solve the following system of equations using any method. Check your solution if possible. So, part A, set up for elimination. So we have the x's and y's on one side, the constant on the other. So I'm going to go ahead and multiply the second equation by negative 2. So the first equation is 6x minus 2y equals 10. And then if I multiply by negative 2, I get negative 6x plus 2y equals negative 4. And when I go to eliminate my x, which my plan was, I actually eliminated both of them and I get 0 is equal to 6, which is not true. So that means we have no solution. And if I wanted to check this, I can't necessarily plug numbers in, but one way I could check this is by taking my equations and solving for y and seeing if they have the same slope but different y-intercepts. So to solve for y, we can subtract x, or 6x. We get negative 6x plus 10, divide by negative 2, and we get y equals 3x minus 5. And then on the second equation, if we solve for y and we subtract 3x, we get negative y equals negative 3x plus 2. Divide by negative 1, we get y equals 3x minus 2. So the slopes are the same, which is what we were hoping for, and the y-intercepts are different, which means no solution is correct. For B, this one is set up for substitution, so I'm going to take 16 minus 2x and substitute that into the first equation for y. Distribute the negative 3 to both terms. Add 48 to the other side and combine my x's. Divide by 7. X is equal to 7, and then take that value and plug it back into the second equation. Would be a little bit easier. 16 minus 14 is y equals 2. So the solution where the lines will intersect is at 7, 2. And we can check this by just plugging it back into both equations. And I went ahead and plugged them back into both equations and checked, and they did both work. So 7, 2 is the solution. Question 63. The less than or equal to symbol represents less than or equal to, while the less than symbol represents less than. Part A. Similarly, translate that symbol. Alright, so that will be greater than or equal to. And then the other symbol is greater than. For part B, how can you write an expression that states that 5 is greater than 3? So 5 is greater than 3. Part C, write another expression that states that x is less than or equal to 9. So x is less than or equal to 9. And then D, translate the expression negative 2 is less than 7 in 2 words. So negative 2 is less than 7. And that is it for question 63.